Hello, this is Mr. Huff, and this is a video about this formula, the Hazen-Williams formula. This is part of the water supply calculation that we need to do for civil engineering, and we'll have some more information about this. This video is to produce a calculator that will help you calculate the head loss due to friction, and this is measured in feet of water. Okay, so if you look at this formula, we've got some bizarre numbers here as far as the exponents. When you see stuff like this is probably an empirical formula or a formula that was generated by lots and lots of experimentation and then using a graph to predict a value. So let's look at the terms we have. We have L for length of pipe in feet, Q for the water flow rate in gallons per minute. We have the Hazen-Williams constant, which is simply a number, and then we have the little d for the diameter of the pipe in inches. Again, because this is an empirical formula, these units will not cancel out. We are only using this formula to get to this number. So putting this in your calculator can be tedious, and we also want to learn how to use spreadsheets. Wouldn't it be nice if I had a way to just put some numbers in and it would do some calculations for me and spit out the answer? And this is what I want you to do. So what we're going to do then is go in and make a Google Sheet, and on that Google Sheet, when it's blank, we're going to fill it in with the information to help us know what to type in where. So this is our Hazen-Williams calculator. I'm going to make this title kind of big. Maybe that's too big. Let's do 14. Okay, so here are my terms. Length, and its length of pipe in feet. Q is flow rate in gallons per minute. We have the Hazen-Williams constant. And D, what we're going to do is calculate the numerator, then the denominator, and then we will complete this by dividing those two. It is possible to put all of this in one calculation, but the chances of making a mistake are very high, and the odds of finding it become very low. So this is my recommendation for you. So I'm going to adjust the size of these columns a little bit, and I want to keep it where I can read everything. One of the things I like to do is anything I'm going to be entering, I like to color code it. In this case, I'll use this light blue color, and I like to have my answer show up in a cell that shows me this is what you're looking for. I'll probably make that a larger number, and let's make these also a little bit larger. So I'm going to increase that point value from 10 to 12. All right. Let's see, we had an example problem in another video, so I'm going to use those numbers or something like that. So let's say we have 17,000 feet of pipe. We have a flow rate of 100 gallons per minute. We looked up the Hazen-Williams constant, it's 130, and the diameter of our pipe is 10 inches. Okay? So now we need to look at this formula. I'm going to split this into two calculations, and then we'll complete the final. So the first one is, let's go look at this. We're going to do the top calculation first. Alright, so I'm going to put equals, and this starts our calculation. We're going to put in the number 10.44. We're going to multiply that, use an asterisk, it's shift and the number 8. That means multiply in a spreadsheet. And we want to click on the one that goes with length. And in this case, it's in cell C4. So C and column C, row 4. This is our length of feet, or length of pipe in feet. And then, so we know that whatever number is in C4 is going to be that length. Okay, we're going to multiply that times the flow rate, and we're going to use the grave. It's the, or the caret, so shift and the number 6. And 1.85 is our exponent. Check to make sure that your calculation here matches what you have for the Hazen-Williams formula, but that should be pretty close. It's going to suggest an autofill, press escape, because it's not the same calculation on the bottom. Alright, so the denominator is going to be equal to the C, the Hazen-Williams constant. I'm going to click on that one. We're raising that, so shift and the number 6. to 1.85 as an exponent. Then we're going to multiply that times the diameter of the pipe, and we're raising that to, so shift and the number 6, and we're going to put 4.8655. Again, double check your numbers here, because if you make a mistake in these, you will get a wrong answer on your calculation. So I double check that. Everything looks good. I hit enter. And now for the head loss in feet of water. So this is basically measuring resistance in feet of water for a system of pipe. Okay, so I'm just going to hit equal, and we're going to click on the numerator and divide that by the denominator, and we get this lovely answer. To make your life a little easier, we can adjust the decimal places. So I'm going to click the left arrow, and that will make it like this. So about 3 decimal places is good. To make this a little, I might make these smaller so they don't get my attention as much. And that is how you can set up a calculator. So now as I change the things, let's say that I have 20,000 feet of pipe. Now it's got a different answer. Let's look and see if this works. So we see in our formula that the number that changes the most is the one that is raised to the 4.8655 power. So that is our diameter. So if we go to 8 inches, we see a pretty significant increase in head loss. And if we go to 12 inches, we'll see that that decreases dramatically. If we go to 6 inches, we get even more, and an unrealistic 4-inch system would have 151 feet of head loss. And then if we go to 2 inches, then that gets to be higher and higher. So that is the expected response there. All right, with this Hazen-Williams calculator, all you need to do is get the values from your question. You can plug those in, and it will tell you your head loss in feet of water. I'm going to make that bold so it stands out. All right, thank you for watching.